Hello friends, welcome to Crack Kit CSE, and in this series of database we are continuing with our file organization and indexing lectures. So in the continuation today we will be understanding what is indexing, what is an index file, how you can find out the block factor for an index file, and what is multi-level indexing and why we are moving on to the multi-level index. So we will be understanding all these things in detail, right? So before starting this particular video, I would like to request you all, if you have not subscribed the channel till now, please subscribe the channel and press the bell icon so that you can get an update whenever I am uploading any new video. So now start with the indexing. So first thing is why indexing is used, why we are using indexing. So indexing is used to minimize the number of disk access required to process a query. So we know that whenever you are processing any particular query, let's say a SQL query, so to process that particular SQL query, we have to access the disk again and again because our database file is stored in that particular disk. So to minimize that disk access, the number of disk access, we are using the indexing, right? So this technique is used for quickly locate and access the data. So if we are using indexing, then we will be able to easily identify or quickly identify the data and access the data, right? So we'll be understanding this with help of an example. Don't worry about that. What is an index file? So an index file will be having two entries, two columns. One is search key, another one is pointer. So this search key is nothing but the primary key or the candidate key of a table which is stored in a sorted array. So the indexing is possible only if the key is stored in a sorted array. And this pointer points the address of the respective key or the block of the respective key, right? How to find out the block factor for the index file? So generally we find out the block factor for the database file by using the formula as b minus h divided by r. So here instead of r we are having k plus p, which is nothing but the size of a row in an index file. In an index file, in a row we will be having key and pointer, so k plus p. So what block factor tells? Block factor tells us how many maximum possible index entries can be stored in a particular block. So let's say this is a particular block I am having in an index file. So this n, the block factor, if the block factor is equals to n, that means we can store n number of index entries in a particular block, and I already told you that in each particular block we will be having a block header which tells the information about the data inside that particular block. So we will be subtracting this header from the block size. Now let's understand this with help of an example. So first understand what is indexing, how you can perform the indexing. So see, here I am having a database file, right? This is the index file. In database file I am having the keys as 1 2 3 and so on. So what is indexing? Indexing is nothing but the mapping of information to a respective index or in a index field, right? So here you can see that I am having 1. So this pointer is pointing to a particular location of the first key, or we can say it will show the location of the key first one block. So the first key, where the key 1 is stored in this particular block, so it is directing to that particular block. Next, this key is 3. In which block this 3 key is here? In this particular block. In which block 5 values here? In this particular block. Similarly 7 is in this particular block. So you can see that I am mapping this set of record to a particular index field. That means I am just performing the indexing here. Now what is the benefit of indexing? If I want to find out the 7th key, and if I do it in indexing, I will be going on to the index file. Here I will be checking that in which particular block the value 7 lies. So I will be taking here, it is 1, it is 9, that means the 7 lies in first block. Now I will be going to 7th place, and by following that pointer I will be easily going on to that particular block in the database file. So this is how we can quickly locate and access the data. Now the question is, Now the question is, why we need multi-level indexing? What is the drawback of single level indexing which is forcing us to move on to multi-level index? So see, this is how we can find out the block factor for the database file. Here we are having code, here we are having k plus v. This is just to show you. Here the block factor is equals to 2 because in a single block we are having 2 entries, and here the block factor is equal to 4 because in a particular block I am having 4 index entries. Now let's come back to the multi-level index, that why we are moving on to the multi-level index. Let's say that in this particular database file we are having more information, and if we are having more information here, then obviously more number of information or more number of pointer key will be here. More blocks will be here. Why more blocks will be here? Because here we will be having only the entries which are equal to the blocks, because each entry is representing a block. So if there are n block in the database file and there are m block in the index file, then obviously then this m should be less than the n, because if we are having here 10 blocks, right, and here I will be storing the information of 4 block in a single block, that means here we need only 3 block, so this m is less than n. And if there is more information in this database file, then there will be more blocks in this particular index file. And if the number of blocks, or we can say that the block size of index file, is very large. What is the meaning of very large here? That if the file size of this index, that means if the index file is having a size more than the main memory, so if this particular index file is having the size more than the main memory, that means this particular index file will not be able to fit in the main memory. What does it mean? That means that we have to store it in a secondary memory, and if we are storing this in a secondary memory, then there is no need to do indexing, because then again we have to access this from the disk, then this from the disk. It will take more time. So to overcome this particular problem, this particular issue, we are moving on to the multi-level index. What is multi-level index? With the growth of database, the index size become large. So if the index size become large enough and the primary index does not fit in the main memory, so the first level index is known as the primary index. If this primary index is not able to be stored in a main memory, then we will be moving on to the multi-level index, right? So we'll be keep on indexing. So we'll be further taking an index to map these values, then we'll be moving like that. In that particular case, we will be able to get a situation where we will be having only one block in the end. Now let's see this also with help of an example. So here you can see that this is the particular database file. This is the first level index. Let's say its size is large enough that we are not able to store this first level index in a main memory. Then what we will be doing, we will be further taking an index file, and now again we are performing the same operation or the same thing. So here I will be having pointer for each values. Let's say the block factor here is 4, so that we are having 4 entries in a particular block. This one will be mapped to this one. This one is mapped to the block where this one is stored. This 9 is mapped to the block where 9 is stored. This 17 is mapped to the block where 17 is stored, and so on, right? So here you can see that again in the second level, the number of blocks in the second level will be less than the number of blocks in the first level, because we are keep on minimizing it. So we'll be keep on doing it unless until we got only one block, and if we got only one block, then we'll be stopping it and storing this one block into the main memory, right? So whenever we want to access any particular information or record for a particular key will going on to the main memory, and here we'll be checking where is the pointer. So pointer will be giving you the location. Then we'll be moving on to the disk, because all these information will be stored in the disk. Then if we are having the address of a particular disk location, we can easily access that in a less amount of time. So this is the main process to minimize the number of disk access, right? Now the question is, how much time it will take to find out the block access, to find out a block. So if I talk about this particular first level index, so this first level index will be taking log m plus 1 time to find a specific key. How? For a particular key, if you want to find out the value, let's say here I am having m blocks, right? So first I'll be checking the value in this particular block, in this particular index file. So I'll be performing the binary search kind of operation. It will take log m time, and after the log m time I'll be getting a specific field for that particular block in the database file. Using that particular location, we'll be moving on further and we can access that in a constant amount of time. So how many block access is required? Log m block access required here, and 1 block to access the location. So if we are talking about the first level index, right, then it will be log m plus 1. Then the time complexity to access a record will be log m plus 1. But if we are using the multi-level index, then the time complexity will be k plus 1. How? We'll be moving on here. We'll be checking, because here we are only 1 block. Here it will be telling at which place you have to go. So we'll be moving on to that particular place. Here also it will be giving you only one particular location. So we'll be going on to the one particular location. Similarly, we'll be keep on backtracking. So if we are having k level index, then k blocks need to access in this particular multi-level index, and 1 block in this file. So total k plus 1 block access is required if we are using the multi-level indexing, right? So I hope you got an idea that how indexing and multi-level indexing work. And in the next video we'll be discussing the categories of index, that is dense index and sparse index, right? After that we'll be practicing a question on these basics of indexing. So if you found this particular video useful, like this video, share it with your friends, and don't forget to mention your comments or suggestions in the comment box. And in case if you are having any query related to any subject or any question, then you can just connect with me on my Facebook page and Facebook group. The link are given in the description. So thank you very much for your support. Keep supporting, keep learning. Have a great day.